Let's get started. I'm Erwin Geirnaert. I have been working in security since 2000. So you can call me a bit of a veteran. Sold my previous company, Design Security, last year, and we rebooted with Shift Left Security to provide offensive and defensive security solutions for critical applications. And what we see nowadays is that everything is API based, so the API security aspect of these applications is very important. So let me just give a brief introduction on why API security is a problem. For me, it's like being back in the year 2000 when we started with securing websites. It's now a bit the same problem with APIs. So, which is not a good thing because everything is relying on APIs nowadays. If you have a mobile app or a single page application or business to business or Internet of Things, everything is connected using APIs, which is of course also a good thing because now you can automate a lot of stuff by connecting APIs, even of security tools. All right. So what is a bit the problem when we talk about security is that from a developer perspective, we're building secure environments or secure applications. Well, we try to build them, but we are using protocols like HTTP, HTTPS, DNS that are in fact not built to do like these kind of critical transactions using internet technology. Also, the languages that we have in place are insecure, like the typical PHP, which has not been built to have a secure solution in place to secure websites and even the APIs, but also the frameworks on top of these languages like Spring for Java or Symfony for PHP or whatever framework that is now hot and sexy to be used. They also have their problems, and you really need to know how to secure them to have a secure API in place. Also, the biggest problem is that when you ask a developer, build me an API, well, if you don't tell him how to build security in, to give him the requirements to secure that API, the developer will often forget to implement additional security controls to make sure that the API is working like it should. And when a developer has built the API and it's running in the cloud or in a private cloud or whatever you have, how does he know that it's secure? Because it's not possible to say, okay, I have built this API, now go test it using a manual or an automated process to make sure that there are no vulnerabilities in that API. So that's also not positive to provide the necessary guarantees that the API is secure. And of course, most developers that I have worked with in the last 20 years, they never have seen any mention of application security when they went to university or high school or in their current job environment. So we cannot expect to have every developer become a security champion. So it's very important that you provide a kind of secure architecture and security framework that they can use to build secure code. And what is happening now that with all the DevOps and now talking about DevSecOps, well, we are giving more power to the developers to not only build the code, but also deploy the code and keep it running. So we give them the full keys to the castle, to the cloud environment. And with that, it can have a huge impact when a new vulnerability is introduced in these API economies. So what I want to talk about in the next 20 minutes is my definition of an API, and I'm talking about anything that is accessible using HTTP or HTTPS, so the real web-based variant of APIs, not the old school like SOAP or even Corba. If people are in the call that know what Corba is, but that was one of the first APIs to have like C and Java applications be able to talk to each other in a distributed network environment. So what we are seeing a lot is that APIs are being used implicitly by, for example, Angular or React. So there is an API, but you don't really know that, you just use it as a feature. But we have seen a lot of security issues there in the last years. Now with PSD2, where we open up the banking informations stored in the typical old school mainframe environments, well, we need to get the data, so the banks need to provide APIs, and that can also give security issues when they're not secure. And of course, the typical way of working with using enterprise server bus, everything is HTTP, HTTPS. But when you make, for example, a mistake of opening your internal ESB to the outside world and there's no authentication in place, it can also be attacked. So, big problem. Okay, and what is now the problem with all those API consuming? Well, when we talk about going to the edge, well, the clients that are connecting to those APIs are becoming more and more powerful. If you have a mobile app, well, a lot of mobile intelligence is also implemented client side. So it means that the shift from security that is in the backend is also going to the front end. So, and there we see also a lot of security vulnerabilities popping up because the developer was not aware that he also need to check or double check or implement authentication or authorization on the backend side as well. All right, so fortunately, there is a very interesting initiative from the Open Web Application Security Project, OWASP, about APIs. So OWASP, if you don't know about it, it is an open source community since 2000. It was active from in the beginning. And the first thing that OWASP tried to do is increase the awareness for developers that security is in fact a big problem when we talk about software. So they created like this top 10 lists of the most critical web application security risks. So it is used worldwide by a lot of companies to create awareness, but also to make sure that when you build software that you make sure that you test that there are no top 10 vulnerabilities in your environment. Of course, it's not a standard and it changes every 2 years because there are new vulnerabilities coming on. So if you want to know more, here's the link to the top 10 for web applications. But what have they done at OWASP? They have different project charters, and each project can have a different view on things. So they extended the OWASP top 10, for example, to mobile apps. They extended the OWASP top 10 to cloud, but also to Internet of Things. And of course, they now created a project for the OWASP top 10 for APIs. So, like it's an OWASP top 10, I only want to give you an overview of the 10 problems, and I will go more in detail on the first 5. So the naming is a bit strange. So if we talk about broken object level authorization, I think it's very important that I will show you what it is, but also the same for broken user authentication, excessive data exposure, lack of resources and rate limiting, and broken function level authorization. These are the, I find, the 5 most critical ones, and also very specific for when we talk about APIs. The next 10 will not be discussed in this presentation, but we talk about mass assignment, where you assign too much variables in your persistency model so that you can change the role of the user. Also very important one is security misconfiguration. I see a lot of environments that are still configured and installed by default, with default credentials, with default encryption keys for GWT tokens, not being protected with API gateways or web application firewalls. So when there's one problem, it is very easy to attack and exploit. Also, a very old problem is injection attacks, where you can inject SQL code or LDAP or XML injection in APIs to get more access. Also, improper access management is that you have several versions of an API online, but version 2 is more secure than version 1, but it's still possible to attack version 1 because it's legacy, it's still there. And a very important aspect that is often forgotten is the logging. Most developers only log bugs, but security violations and security attacks, but also attempts to bypass security controls are also very important to log and to alert on, and not only have the log sitting in somewhere in a file system on your web server that you only look at when there is a real problem. And it's of course too late. Okay, so when we work in IT, we are always confronted with an acronym, and this is a new one. It's called BOLA, Broken Object Level Authorization. And it's a very, very common problem, because when we talk about data and when we want to access data in a database, it's often driven by using public primary keys or whatever you think of an identifier to access the data. And it's of course the functionality of the API that when you want to get a document, for example, from an API with number 1000, that the API will say, hey, this is a valid document number, I will give you back the document. So we have the same problem with in a web application where, for example, when you want to make a banking transaction from somebody to somebody his account from your account, that when you can change that account number to somebody else his account number, you can wire money from somebody else because of the use of the direct object reference. So it means that the account number is really used as the key to make the call to get money from that account. So that's why we mentioned here that's like an indirect object reference in web applications. But the main problem here is that we don't implement authorization checks on the document level to make sure that, hey, is this guy allowed to get document 1000? Yes or no? So this is something that needs to be implemented on the API layer, and the same for any other request. So what is very, very important is that when you are using an API, that in every call to get data from your database or file system or whatever you're using, is that to check that the call in the API is authenticated, so you get the identity of the callee, and that you check, is this user allowed to get that data? And when it's not allowed, is that you will just block it, but also create an alert that somebody can see, hey, somebody is really trying to attack our API, because it's only when you know that you're under attack that you can get additional budget to improve the security, right? But what we have seen as well is that some APIs don't require authentication at all, because they trust, for example, the front end or the mobile app, that when you know that there is a /API/getUser/ID = 1, that if you only know that, then you're allowed to call it without checking anything at all. So which is a very, very bad situation, of course. So a few years ago, there was a big problem at T-Mobile, the telecom provider in Germany. So you could call an API with just sending as the authentication method the mobile phone number. There was no authentication that you had, that it was your phone number. So people could really get all the information of who has a specific phone number, and they could use it to create fake SIMs to spoof or swap that number as well. But also it is very easy, and we are developers, you know, that you can really easy generate all the possible numbers that exist there, and you just send them to the API. And when you don't detect that kind of attack, well, you just say, this is a good number with all the data, this is a bad number. And of course, in the GDPR area, this can result in huge fines. Okay, so if you have any questions, don't hesitate to put them in the Q&A, and then we can discuss after the slides. Another one is broken user authentication. It means that we can bypass authentication implemented to secure access to the API. And it's very, very common that there is too much trust, either on a network connection layer or on misconception that front end will authenticate the user, or that there are just hard-coded credentials or trust in GWT tokens without checking the content. So recently I was able to log in as any user in an application because the GWT token did not have proper encryption and digital signature implemented to protect the user ID that was stored in that token. So I could just create my own GWT tokens with my own user ID, and then was having access as any user. Of course, it's not always that easy to understand the concept. So when people tell me, well, we have implemented OAuth, then my first response is, okay, you implemented an authorization protocol, but you did not really implement any authentication. So it's also very difficult to have a good approach. And also like hard-coded API keys that are very easy to predict. Like if I see an application that gives me a key of 1, 2, 3, 4, then I know that the guy that created a new API key before me will have a key like 1, 2, 3, 3, and the next one will be 1, 2, 3, 5. So if I can just create my own API keys, I just bypass authentication as well. And of course, with modern apps that redirect to single sign-on services or to specific identity servers, if you don't implement the best practices, it is very common to find flaws to bypass that authentication. And of course, when we have like mobile apps or Internet of Things devices that stored hard-coded API keys, it is very easy to reverse engineer that and abuse the keys. Give you an example in the next slide. But also very common is that people are looking in Git repositories to find credentials that are just hard-coded in the code and that will work on any application that is using that code base, which is also very, very bad. As an attacker, how can we attack this? Well, there are often specific additional calls in the API that are less protected than when using a web application. So the web application can, for example, implement extra protection like account lookout when there's too many attempts to guess username password, or to show a CAPTCHA, or to protect against credential stuffing, but that's on the front end layer. But when we know that the front end is calling the API to do, for example, a login or forgot password, and the checks are not on that API level, well, we bypass the front end and we immediately start attacking the API. Or also a big problem is a misimplementation of your Java web tokens with the algorithm none. So it means that your backend is not checking if it's a valid token generated from your backend as well. Or that your service provider that does authentication is not validating the OAuth, or that passwords are stored in your backend without salt, so that when we are able to dump a password, that we can easily do an encryption attack to find a clear text password, and so on and so on. So a lot of problems exist in this area. So to give you an example of how easy it is to for example, breach Internet of Things devices. So this is an example of a security company called Pentest Partners, where they just wanted to have a jacuzzi, of course, and well, they said, well, let's look how it works. So they found that there was an Internet of Things appliance in the tub somewhere, and that when they looked at it, they see, we have a mobile app that allows us to heaten the jacuzzi when we're, for example, still at work and we want to go home and we want the tub to be hot enough to enjoy a very nice jacuzzi. Well, when they looked at the Android app, which is just plain Java code, you can decompile it using JEDX. They found hard-coded credentials that allowed to access the API, because the credentials were the same for every mobile app, so for every customer that bought this jacuzzi. So when they noticed, okay, we can try these credentials, well, they were connecting to this kind of XML API, where when they logged in, they were seeing this URL with a collection name, with some reference to their environment. But of course, when you're a pen tester, when you see something like this in the URL, the first thing you do is you remove that identifier, of course. And then they noticed, well, we can see all the other jacuzzis out in the world that exist, so this is real privacy violation. But they also noticed that they could use the knowledge to see if somebody was at home or not by checking, is my jacuzzi on, yes or no? Okay, sorry about that. So that was broken user authentication. Another one is excessive data exposure. So we have an API and developer knows, okay, when somebody calls get user or get data, that we need to return all the information stored in the database for that specific user or that specific data or function that is being called. But sometimes they send back too much data to the client. And in security, we always say never trust the client, because we always have full control of what happens to a client. So for example, when you have like a generic function like toJSON from your relational model, that everything in the database is just returned as JSON data from your API, you can leak sensitive information as well. So here's an example which is very bananas or peanuts. And so it's a super safe app. So the user Bob logs in, his name is Bob, he has a role minion, and his hobby is bananas. But at the moment when the mobile app makes a connection to the API, it's sending, of course, the user profile information with identifier, but it returns as well the address of that user. It is not shown in the app, but the data is coming from the database. This can be become a real privacy issue, because the address should not be leaked on the client side, because when we do a man-in-the-middle attack by intercepting the traffic from this mobile app to the backend, we can see the data. And of course, if we know then that there is no authorization on this identifier, we can start getting the data for all the users from that backend. And there was a big problem with a specific app to have very hot dates with a lot of people, also from the pen test partners company. So they noticed when you registered and installed the app that you could find back the geolocation of the user when he was last connected to your environment, but also the links to the S3 bucket storing his private photos as well. So they were not shown in the app, but by looking at the traffic, you could find all the private photos as well, which is again another security issue. But you can imagine that most people wouldn't like to have this data leaked. And another one was very recent, is from the Vatican. So you now have like this Internet of Things device, the rosary bead, where you can pray and it will count for you how much you use the rosary. So to get access to this backend, you need to register, and then if you forgot, of course, your email address, you could do like a password reset. But there was a problem with the implementation of the password reset. So when you did, hey, send me a 4-digit PIN to my email address, the moment when you send your email address to the backend API, which was living on a very easy URL that was found by looking at the mobile app, the API returned the PIN code as well in the JSON response. So instead of sending it only by mail, it replied it to the app as well. So any attacker could reset any other user his credentials on that platform, because the PIN code was leaked from the backend as well. And then, of course, these guys made it very easy to make a a small code to do this automated for every user. And now, of course, because it's an API, it just works. Okay, number 4, lack of resources and rate limiting. It means that your API is not protected against denial of service attacks or brute force attacks. So if you know that somebody can try to guess identifiers and that it allows to guess username passwords, and you're not detecting or blocking thresholds, then it can be abused. For example, a big problem was in 2016 that Facebook was implementing rate limiters in their online website, but not in the beta and the mobile basic site. So when you know that, you can just start guessing passwords for any username or mail address that you have, which is of course being abused by the phishing guys that really want to steal as much data as possible. And it's not because your API is hidden under api.yourcompanyname.com that nobody can find it. Everything online is being indexed, and it's very easy to use Shodan or Census to find APIs for specific companies. Or like here, if I go to Census and I search for API and look at the certificates for Belgian countries, you see here, okay, I now know that there is an internal API for the e-health of the FGov, but for Forum, or also for I think there's a bank here. So you see that it's very easy to find the full domain name to access the API. And of course, there are a lot of bug bounty hunters that really try to abuse these things to get a lot of bounty. So, for example, this guy from India was able to hack Instagram. So when you did a password reset using the web interface, you received a link in your email with a one-time code. So it was very difficult. But when you did it using the mobile app, you received a 6-digit code. So it means that you had like 1 million characters that you need to guess. So if you have very strong computers, which are very easy to hire nowadays with cloud, and you have enough time and power, you can just do 1 million attempts clustered over 100 VMs, and then it's very, very easy to guess the exact 6-digit code, and then you get full access to the Instagram account of that user. So here again, you did a post to an API user lookup. You need to know the mobile number of that user and the device ID, which is of course a request coming from your mobile app. And then the victim will receive a passcode that will expire in 10 minutes. But if I have 1,000 VMs, I can do a lot of requests in 10 minutes to get that recovery code very easily. And of course, the guy that found this just got like $10,000 or $20,000 for that bug. And then the last one is E5, is broken functional level authorization. We're not talking about object, which is the data, but here it's the function. It's the function call where there is not enough authorization implemented. Who can access that? And so it can be either implemented by code by a developer, or it's in a configuration file, or it's on your API gateway. Well, it's very easy to guess this when we talk about APIs, because the endpoints are more predictable. So here, for example, in the traditional app, we need to guess users view, ASPX, whatever. But in an API, it's just doing a get v2 users with the user ID. Same for delete. Here we can delete it. So when we know, okay, we can do a get, well, if we can do delete, we can delete all the users in that backend API. So this is a legitimate attack. Well, if the malicious guy also knows that he can access that function, it can be a big problem. For example, also from the pentest partner guys, they found that there was a big vulnerability with a smartwatch platform for kids. So at the moment that you logged in, the API would give you back parameters with your access grade as an integer value without any encryption or security at all. So you could change the grade to become full administrator on the platform and see all the possible watches of all kids that have purchased that watch. And of course, it's a big price evaluation again. You see that there are a lot of watches already sold. Just by changing this to one, you could become from a normal user here to a full administrative user of that web interface. So another problem here is that you have one API where backend admins and front-end and normal users all able to log in or create an account. Okay, I hope that my timing is rather fast enough. And now maybe it's time to see some questions.
Yeah, so we received 2 questions. The first question is basically, why do we limit the definition of APIs to HTTP? And why don't we see it a little bit broader and also include old school file-based transfer? How would you link that to your talk?
Okay, well, of course, we have to look at how the things are evolving. But if you talk about file-based protocols, then we talk about probably something like SFTP, where you do like batch processing, sending information from one environment to another. This talk is more focused on a real full synchronous getting data, pulling and pushing and all that. So that's the difference. Of course, there are some differences because SFTP or file transactions using batch, it's a total different way of looking at things. There is no real an application that is accepting data. It's more like a protocol, like an FTP server. And then you have a script running on that side that will get the data from that file and store it in do ETL, store it in database for further processing or do some other actions. There a lot relies on the security and how can you secure access to that FTP server.
Yeah. Then another question we had was, do you consider a private cloud a threat to security? And how would you see the impact if everybody would start its own private clouds?
Well, it's a very good question because there's no easy answer. First of all, private cloud can be more secure than public cloud, but it all depends on how you configure, keep it running, patch it, secure it. It's not because you run it on your own, in your own data center, for example, with OpenShift. You still need to implement additional security controls to make sure that your OpenShift environment stays secure. You need to do vulnerability scanning, you need to do intrusion detection, do log consolidation, have secure applications running on that environment. From privacy or lock-in perspective, private cloud is of course better because you control that, you have full access and nobody else. Where in public cloud, you have the segregation of duties, but also you rely on your cloud partner and you need to trust them. Of course, I think that when you look at the typical Amazons or Googles or Azure companies, they have, of course, now the experience of providing a secure platform where some cloud startups may still have to learn a lot about with vulnerabilities and with instant response, that it's not always that easy to do it. So it all depends on your use case and your own maturity on securing the information. I think that a lot of companies that are having their own data center and are now looking at going to public or private cloud, it all depends on your own expertise. If you don't have any expertise in-house on running a private cloud, then it's much better to go to a public cloud where it is fully managed for you, and you can just look at deploying your code. And of course, with cloud native and serverless, I see a lot of advantages there, that you don't need to patch your operating system, that you can have an immutable production, and that you don't need to have access to production even more, so that your developers, they just create code and it's just being deployed, all automated. That's the beauty of going to cloud.
Then the next question is, could you explain in more detail OAuth as authentication versus authorization mechanism?
Okay. So OAuth is in fact an authorization protocol. So it means that when you want to access a protected resource, the OAuth token will be used by the backend to see, is this user allowed to access that resource? That's the difference. There is in OAuth version 1 or version 2, there is no authentication protocol at all. The only thing there is that after successful authentication, OAuth will give you the token that belongs to your authenticated user. But how to do that authentication, then it's a bit of a problem, because it's not in the standard or in the protocol. So, and that's very confusing for developers. So, for example, when you talk about OpenID Connect, which is, well, first of all, you have OpenID, and OpenID is in fact an implementation of OAuth with authentication as well. And of course, the last version of that is OpenID Connect, which is in fact a combination of an authentication and authorization protocol. And that's what if you need to authenticate somebody, you need to look at that.
Yeah. And then the next question is, do you have any good references for tooling in helping out securing APIs?
Yes, so first of all, securing APIs, it can be done nowadays by writing your APIs with the Open API contract, so that you have a formal definition of your environment. And there are no, for example, startups like 42Crunch mentioned on my slide here, that allows to scan your Open API contract to see that there are no flaws in that configuration already. So it will look at the contract and it will say, okay, this method is not protected with authentication or authorization. This method is not implementing input validation and so on. And then it also has a scanning tool to scan the API when it's online. And it also have like this micro container with an API firewall that will protect the API based on that contract as well. So it's fully integrated with how the developer works. For example, if you develop your API in Visual Studio, that you can even integrate with that as well. Of course, if you have already legacy APIs and the API state, then we can use the API discovery and API security testing service of EdgeScan, where we can do a full manual penetration test of the API to find any existing vulnerabilities if they're already online. And then, of course, the next step is to really secure the API by either implementing additional controls in the code or on an API gateway, API firewall layer.